Okay, so the next problem I'd like to look at is problem 6.4. So let's see if we can find 6.4. And this is one where you all know that the winning the lottery is not something that's really likely to happen, but everybody does it anyway. So this person, Howie, just learned that he won the lottery, $500,000. 2 payment options: he can take all the money today, and the government will deduct taxes of 46%. Or you can take 20 equal payments, annuity, of $36,000 with the first payment when Howie turns in the winning ticket. Okay, so right there, that tells you that's kind of a now thing, so this would be an annuity due, because the first payment starts right away. So assuming you can earn 8%, compounded annually, which payout should he choose? Okay, so how do we set this problem up? The first thing you want to do is option 1. You can get the $500,000 now, 46% tax rate. The tax would be $230, so we'd net $270. Okay, so then to set up the second one, you have 20 equal payments starting now. So you're looking for the present value of an annuity due with n equal to 20 and the interest rate of 8. So you get to the, you just go to the regular old present value of an annuity table, you find the factor, but then you have to multiply it by 1 plus the interest rate, and this takes care of the annuity due part. That adds the extra time period that you need there because the payment happens at the beginning of the month. So this gives you the factor that you should use of the 10.603602. So you compute the present value, you get the $36,000 payments. So the present value of all of that comes out to $381,730. But the tax rate on this, because it's over those period of years, is going to be 25%. So the taxes are $95,432, and so Howie would net $286 as opposed to $270. So we should choose the annuity. Okay, so that's problem 6.4. The other one I would like to look at is, probably not 6.5. 6.6 I'm going to do separately, but I would like to take a quick look at problem 6.7. Okay, so let's just take a quick look at that. Oh, here's 6.7. Oh, here we go. All right. So the company has some money to invest. They've got 2 alternatives. They can get $80,000 at the end of each year for 12 years, or they can get a single lump payment at the end of 12 years. And so which should they choose? Okay, so alternative A, you notice that they don't give us an interest rate here. So you've got $600,000 to invest now. You know that you're going to get $80,000 at the end of each of 12 years. So do you need to know the present or the future? We know both. We need to know the interest rate because assume the interest rate is constant over the investment, but they don't give us what it is. So they're really asking which one would you earn more interest on. So to set up the problem, you could say that the 600 is going to be equal to the present value times those 80,000 annuity payments. So this is the present value factor for an ordinary annuity of 12 periods, but an unknown interest rate. So you do the 600 divided by the 80,000, and so this solves for the present value factor, which is 7.50. So you go to the correct table, the present value of an annuity table. You go across to the 12 years, and then you find the closest factor, which is 8%. Okay, that only gives us alternative A. Alternative B is we're going to receive a lump sum payment of 1.9 at the end of 12 years. So here, we know both again, and we need the interest rate. But this is a single sum. It's a lump at the end of those years. So here, we're going to say the 600 we've got now is going to be equal to the 1.9 discounted back the 12 years at some interest rate. And so we go through the same process of, we do the 600 divided by the 1.9 gives us the factor, okay? We're just solving any, like an ordinary math problem. You could call this x if you wanted to. So you're just going the 600 divided by this equals x, well, the factor that you're looking for. And when you go across 12 years on the single sum table, you're going to get 10%. So here, would you earn 8%? Here, you would earn 10%. Oh, and then it keeps going here. You just completed the purchase of new computers. The fair value is given here. The purchase agreement specifies an immediate down payment, and then semi-annual payments beginning at the end of 6 months for 5 years. And they're asking, what's the interest rate? And this sounds complex, but it's really, you're setting it up almost the same way. You know both. You need the interest rate. It's an ordinary annuity. You've got the N is 10. So you've got the purchase price was the $824,150. And this is where they add the complications that I'm not going to do to you on an exam. Plus you take off, or minus, you take off the initial down payment. So the amount to be financed is the $624,150. So the $624,150 is going to be equal to the present value factor of the ordinary annuity, 10% at some interest rate, times the payment amounts. So you divide them out, get the factor, go to the table, 8%, okay? So that's what's the interest rate to the nearest percent. Now he wants to loans $800,000. He accepts a note, 8% note, due in 7 years with interest payable semi-annually. Oh, yeah, and notice when you're doing this, it's 5 years, but it's compounded semi-annually. So the factor we're using is 10, okay? All right. All right. So again, we've got this is compounded semi-annually as well. So what amount will you receive? So he takes the $800,000 times 8%. The interest payments are $64,000 a year, but divided by 2 gives you $32,000 annual interest payments needed. So this is similar to computing the present value of a bond because you've got the two income or the two cash streams. You've got the single sum that's going to be repaid, but then you've got semi-annual interest payments of an equal amount paid over the time period. So your N is 10, 5%, and so you get the factor for each, add them up, and that's what you should get. Okay, so, oh no, now what else is he doing? He wants to accumulate $1.3 million to retire bonds. So they deposit $200,000, 10% quarterly. In addition, the company wants to know how much should be deposited at the end of each quarter to ensure that they've got the money to repay the bonds. So we have to determine how much is already taken care of, okay? And then we need to know the future value of the $200,000 deposited already. So, yeah, this is a problem that's way more complex than I would expect you to be able to do at this point, but we'll keep going through with it. So you do the future value of a single sum, and it's quarterly for 10 years, so it's 40 and 2.5%. I don't think our tables do that, 2.5. So the amount already taken care of is the 537,012. And so the remaining amount needed is the 762,988. Okay, so now you can do the rest of the problem. You know the present and the future and the interest rate, so we need to know the amount of the payment at n equals 40 and I equals 2.5. So this times something, or times the amount of the payment, this factor times the amount of the payment equals the 762,988. You solve for it and get to the payment. Okay, so those are just a few of the problems that I go over so that you can have at least an idea of how to set them up should you ever have the misfortune to need to do that. Okay.